one more video about the normal distribution. This time about the z-score and how do we use it. Alright. It's another measure for normal distribution other than the 68, 95, 99.7 rule that we've used previously. Z-score means how many standard deviations is the value away from the mean. Alright, so if we look at, for example, a value of 62, how many standard deviations is that away from the mean? Alright, in the graph that we looked at, the mean was 50 and standard deviation sigma is 5. And we need to remember that. So if we look at a value of 60, that is 2 standard deviations above the mean. Z-score is then 2. Easy. Alright, so 2 standard deviations above the mean means a z-score of 2. Alright, what if we now look at 35? 35 is 3 standard deviations below the mean. Alright, so this would give a z-score of -3. Alright, so below the mean, negative, above the mean, positive. And the mean itself has a z-score of 0 because it's no standard deviations away. Alright, so here are the z-scores on the bottom. But again, it's not always that easy. So sometimes it will be between 0 and 1 or between 2 and 3. Alright, so we're going to look into those situations as well. Alright, we'll use the following formula. X minus x bar, so the value that we're looking for minus the mean over the standard deviations. What it actually does is you're just looking at the difference between the value that we're looking at the mean, how far is it from the mean, and then the standard deviation, we divide it because we want to know how many times does the standard deviation fit in the distance. That's sort of what it does. So if we look at a z-score for the number 62, we're going to use this. All right, remember that the mean was 50 and standard deviation was 5. And z-score is 62 minus 50 and then divided by 5. So 12 divided by 5 gives us a z-score of 2.4. All right. So what do we do in actual z-score? A z-score is used to calculate probability when values are not exactly whole standard deviations away, right? Because sometimes what we've done previously, the standard deviation was either 1, 2, or 3 away from the mean. So now we're looking at situations where it's in between, just like the z-score of 2.4 was in between 2 and 3 standard deviations away. Alright, so what's the probability of getting a value lower than 46? These kind of questions are the questions where we use a z-score. Alright, start with the finding a z-score of the value. That's what we're going to do first. Alright, so we have the formula here, and we're putting it in. Alright, so we're using the exact same example where the mean was 50 and the standard deviation was 5. We have a z-score of -0.8. Alright, now again we're looking at the probability. And to find out what how to do that, we need a z-score table. Alright, there you go. This is a z-score table. And in the z-score table, you see values for z in the first column and the first row, and those combined make a value. Alright, so the top first corner is -1.40, right? 1.40. And well, that's how you use it. Alright, what it calculates, what it gives us, if you look at the -1.40 on the top, that value of 0.0808 is the probability of having a z-score of -140. Alright, and that is the actual area underneath the graph. That's again what we're looking at. And it's always to get that or less. What is the probability of getting a value lower than 46 was the question we were working on. Alright, we found a z-score of -0.8. And because you saw on the table that it's always looking at 2 decimals, we have to make sure to add the third or the second decimal being 0. Alright, this is how we use the table. First you look in the column on the side and you look at the first decimal. Right? The first decimal was 8, -0.8, and the second decimal was 0, non-existent, and we have a probability of 0.2119. Okay. That tells us the actual probability. So probability of having a 46 or lower is 0.2119. That's the probability of having a 46 or lower if we look at the coin toss that we've been looking at in the previous videos. Alright, now a different one. A normal distribution with a mean of 36 and a standard deviation of 2.5, what is the probability of getting a value between 29.5 and 34? Alright, so in the table you can see in a graph here on the left, the probabilities in the table are always lower than the actual z-score. So I'm going to show you how we do that. Of course, we start with finding the actual z-score. So for 29.5, the z-score is something with a lot of decimals, so we round that to be approximately negative 2.71. We do the same thing for 34, and we get a z-score of negative 0.83. We go to the table again, and we look at negative 2.7, and then at the row 0.01 to get the second decimal. And we get a probability of 0.0034. So that's what we use. Alright, for negative 0.83, we get a probability of 0.2033. Alright, again, small probabilities. So back to the example that we had. For P, the probability of a z-score smaller than or equal to negative 2.71, we had a probability of 0.0034, and the probability for having a z-score smaller than or equal to negative 0.83 was 0.2033. Alright, so we need those values. Now looking at how we actually use this. Alright, if you look at the graph here to the left, we're looking at an area in between two values, and this area we need to find what the actual measurement of that area is. Okay, so now I put in the values, and you see that the 0.2033 from the 34 range is the orange part plus the white part, and the white part is just 0.0034. Well, if you look at that, it actually makes it kind of easy. Alright, so we're looking at the difference of the two probabilities. The probability of having anything lower than 34 is 0.2033, and the probability of having something smaller than 29.5 is 0.0034. Well, we want it in between, so we look at the difference. So we get a value of 0.1999. And that's our probability. And that's what we do, and that's how we use our z-score to find probability that is not exactly standard deviations away from the mean. Thank you for watching, and good luck with your homework.